Welcome to Ask and Learn.
We are given strings, or sets of strings, I should say, and a deterministic finite state automaton, and we are asked to determine whether all the strings in these sets are recognized by the automaton. So the automaton is the one in figure 1 from the book, so you may want to reference that. In part A, we're given the set, which is the clean closure of the set containing 0. And now we know that this set contains any sequence of zeros. And I'm going to draw a table with 3 columns. So we have the input, we have the start state, and we have the next state. So we see that if we take a non-empty string from this set, then the first input is going to be a 0, and of course our start state is S0, so it follows that the next state is S0. The next input is 0, our start state is S0, so that our next state again is S0, and we see that this pattern is going to continue until we reach the last input, which will be 0, and at this stage the start will still be S0, and so it follows the next state will again be S0. And we have that S0 is a final state. Therefore, it follows that the strings are recognized by the automaton. In part B, we are given concatenation of the set containing 0 and the clean closure of the set containing 0. We know that the clean closure of the set containing 0 contains any sequence of zeros, and so it follows that this set contains any sequence of zeros with at least one 0. So what makes this different than the previous part is in the previous part we could have an empty string. Now, the fact is this is almost identical to the previous part, except for now we're not considering the case where there's empty string. We saw that in the previous part, even if we don't have an empty string, we have that we're always going to end on the state S0, and S0 is a final state. So it follows that all of the strings in this set are going to be recognized by the automaton. In part C, we are given the concatenation of the set containing 1 and the clean closure of the set containing 0. Again, we know that the clean closure of the set containing 0 contains all possible sequences of zeros, and therefore it follows that this set is going to contain a 1, or contains strings containing a 1 followed by any sequence of zeros. So this is going to be a little bit different than previous parts. Again, I'll draw a table. We have the input, the start state, and the next state as the columns. And we see that our input, no matter what string we take, is going to be, first input is a 1, and our start state is S0, so it follows that our next state is going to be S1. However, notice that in this case, so we have that 1 is an element of this set, since the empty string is contained in the clean closure of set containing 0. But we have that S1 is not a final state. Therefore, it follows that the string 1 is not recognized. So it follows the automaton does not recognize all the strings in this set. In part D, we are given the clean closure of 0, 1. This contains all strings containing any sequence of 0, 1s or the empty string. Now, we have that if a string is non-empty, and again I'll draw a table, so we have the input, the start state, and the next state. If our string is non-empty, it has to at least have a 0, 1 in front. So our input first is a 0. Our start state is S0, so it follows that our next state is S1, S0. And our next input, possibly the final input, is S1, and our start state is S0, so that our next state is S1. Okay, so we see that in the case of the string 0, 1, this is not going to be contained in the automaton. It's not recognized by it, because S1 is not a final state. And we see that in general, we can continue this pattern. So if the next input were a 0, as would be required, then our start state is S1, so that our next state is going to be S0. And the next input would be a 1, and so it would follow that the start state S0 would become the next state S1. Once again, not a string that would be recognized by the automaton, since S1 is not a final state. And we see in general, this is going to be true. So if our input is 0, then our start state is going to be at S1, and our final state is at S0. And next input has to be a 1, and it has to exist. And our start state has to be S0, and so it follows that the next state has to be S1. And S1 is not a final state. So it follows that no non-empty strings are going to be recognized by the automaton. And in part E, we are given the set which is the concatenation of the clean closure of the set containing 0 and the clean closure of the set containing 1. Now we know that the clean closure containing of the set containing 0 contains all sequences of zeros, and the clean closure of the set containing 1 contains strings which are any sequence of ones. So it follows that this set contains strings containing any sequence of zeros, possibly an empty sequence of zeros, followed by any sequence of ones. Again, possibly an empty sequence of ones. And once again, I'll draw a table. So the column on the left is the input, and then next to that, the start state, and next to that, the next state. And there's a few different cases to consider here, but I'm going to pick a case that shows that in general, a string from this set is not going to be recognized. So we're going to suppose that the string from this set has at least 1 0 and at least 1 1 in its sequence. So our first input has to be a 0. Our start state is S0, so that our next state is going to be S0. And we see that this pattern is going to continue so that if our next input is a 0, our start state is still S0, and our next state is still S0. This continues through all of the zeros. And then we move on to the ones. So our next input has to be a 1. Our start state is S0, and so our next state is S1. Now see that if we stop here, we already have an example of a string which has an end state which is not a final state. So S1 is not a final state. Now, suppose, however, that we were to keep adding ones. So we add another input of a 1. Our start state is S1, so our next state is going to be S2. But again, S2 is not a final state. So this string would also not be recognized. And now let's add just another 1 to see what happens. Our start state is S2, so our next state is going to be S0. This string would be recognized because S0 is a final state. And so we see that some strings are not recognized. And if you wanted to be precise about this, we would say that strings with a number of ones not divisible by 3 are not recognized. And finally, in part F, we are given the concatenation of the set containing 1 and the clean closure of the set containing 0 and 1. So we know that the clean closure of the set containing 0 and 1 contains any sequence of zeros or ones, or the empty string. In other words, it contains all possible bit strings. So it follows that this set contains all bit strings starting with a 1. Now, all we have to do is look at our first input. It's a 1, and therefore follows, since our start state must be S0, our next state must be S1. So already, if we just consider a string with no zeros, with just a single 1, we already have a string that is not recognized. Because S1 is not final, it follows that string 1 is not recognized by the automaton. And in fact, this can be generalized to many more strings. So we can just say that not all strings are going to be recognized.